Let's start for today's office hours. Unfortunately, Brandon is busy today with some, airport check-in. So I'm on behalf of Brandon starting off today's office hours. So um, welcome everyone. Let me just introduce myself quickly, and then we'll go over one by one for a short, quick introduction. And then we'll look at today's whole agenda. Like we want to discuss very interesting topic today about the selection and why we should choose the programming language that we choose. So this is Umesh. I'm from India, Pune city, and I've been doing embedded software development past 10 years. Presently, I'm engaged in IoT projects. So my profile includes hardware and software development. Thank you very much. We'll go next um, to Rafael. I hope Rafael is here.
Yes, just some pop-ups.
Yeah.
I'm Raphael. I was invited by Carmoulier of Beetle, who I meet regularly at the Embedded World, which is also next week. And I met him there for first time. I live in Nuremberg, so for me it's easy. And I am for a couple years embedded developer, started out with C and C++ in a at least safety adjacent field in the rail context, and went to automotive doing Rust on embedded Linux. So not really embedded, it's cheating. And now I'm more in an even more Linux-focused world with network monitoring, but I have a side job where I continue to do a bare metal embedded now with Rust.
Great. Happy to have you, Rafael.
Thank you.
Yeah. So let's go to Peter.
Hello, everyone. I'm Petr from Czech Republic, Europe. I work as a freelancing hardware design engineer. So, yeah.
Great. Thank you very much, Peter. Let's go to Navdeep. Hi, Navdeep.
Yep. Hi, everyone. Yeah, I'm an electronic designer from Bangalore. So I work on RF and communication systems majorly.
Okay, cool. Let's go to Srisha. Hi, Srisha. Your mic is off.
Hello, guys. I'm Srisha. I'm from Bangalore. So I work as embedded engineer. So I worked mainly on Wi-Fi and Bluetooth modules. So that is my experience, I would say. Yeah.
Cool. Great. Let's go to Mike. Hello, Mike.
Hey everybody, Mike Fran. I'm in the U.S. I do a lot of consulting and advisory work and fractional work for IoT companies, particularly kind of the intersection of hardware and software and connected devices.
Yeah, cool, great. And let's go to Brandon. Brandon, if you want to say something.
Hi guys, I'm Brandon. I like airports and long walks on the beach, and I'm on my way to Embedded World. So sorry I was a little bit late. Thanks for filling in for me, Umesh. Sounds like you're doing a great job.
Yeah, thank you very much. And Syed and Wafa, do you want to say something?
Yeah, hi. This is Syed Junaid from India, from Visakhapatnam. I work with Andhra University as Emerging Technologies Manager.
Cool, cool. Thank you. Thank you.
Hi,
Amazing.
I'm Wafa. I'm from Algeria. I'm an embedded system engineer, and currently I'm working in the robotics field.
Cool, Wafa. Thank you very much. Thank you very much. And let me take the screens for the presentation, and then we will move to the agenda today. So we're going to start off with welcome and introduction. That's what we already have done. And then we will take the topic, pick your programming language. This is a very interesting topic to talk, and we have very special guest today, Rafael. And then we'll take community questions. And then, like every episode, we look at how we can get 1% better by next week. And then we'll take some questions from the community. and design tips resources, and we will talk about what in the future you can expect into the server. So let's focus on today's agenda. Pick your programming language. I think we all have been uh, using C programming, right, from the beginning of embedded system, and Arduino, which is a popular framework, it's a C++ environment, and Python is everywhere these days. More recently, Rust is the programming language which is taking momentum. We see more and more popularity, more maker, creator, even the professionals online talking about it. So I want to take the opinion from Rafael and take the first question, that what makes Rust become your favorite programming language for embedded systems?
Oh boy, how much time? I mean, yes. Let me preface this. I am a total fanatic, so take whatever I say with a bucket of salt. But what does it do to make it the favorite for me? Is it yes, it is the favorite. I was a C programmer and I like C. And I feel like I can express what I would do in C more easily even in Rust, because I can do more compound operations and I can still see the underlying assembler that will be generated in a similar way than if I were programming C. And at the same time, I have this feeling that if it compiles, then it works. And it usually doesn't compile because there's something wrong. And then I get a diagnostic and I check it. And then if in the end, after 15 round trips with the compiler, I have a binary which I deploy, and I do not have any misbehavior from that binary.
Okay.
And this is the good feeling that it gives me. Yeah.
Yeah, amazing, Rafael. I have some interesting question, my personal curiosity, and I hope that would be fine for you. So how long you been using Rust, by the way, in the embedded
professionally?
Yeah.
Professionally about 3 years.
3
The first 2 years were embedded Linux. Now it's like in the data center. Not professionally, about 5 to 6. I can't really pinpoint when I really started, because I was, as I said, a C programmer and did many things in C at that time. But it's been on my radar, and I've been in love with it as much as you can be with a language, for about 4 years. Yeah.
Okay, amazing. By the way, I'm very curious, and I think the audience is also curious. Everybody would be curious, like what target device that you're working on, and which you would suggest if somebody wants to start with Rust. And how is your overall journey learning Rust when you moved from C and C++ to Rust?
I just took the dev boards or the hardware that I already had from my job. There was like boards that we did, and I just took some of those and deployed Rust on those. And these were STM32 chips, F4 or G4 chips. Mm-hmm. But the target I'm working now is an STM32 F042, which has 6K of RAM. And 32K of flash, which is a little bit of a challenge, but it's kind of fine. And the problems tend to scale with the chip size. So it's nice to have this kind of small chip working. But also I'm doing software for a Raspberry Pi, which is fun. Cross compilation, obviously, is always fun. In terms of what would I recommend, you can't really go wrong with a Pico RP2040 device, or even a Pico W. That will also get you into a nice space where you need some of the concurrency if you're using the Wi-Fi, for example, or Bluetooth. And there's some async and await goodness in Rust that makes this a charm. Also, the ESP32 boards are hardware that actually has official vendor support for Rust, and it tends to be high quality. There you can even, like RP2040 is somewhat limited in performance, but an ESP32, they have quite beefy dev boards that you can do a lot with.
Amazing point, Rafael, that you make, and I'm very happy to hear your thoughts. And since you
Thank you.
talked about RP 2040, it's amazing to bring in Wafa here because Wafa been using MicroPython, I guess, right? And hi, Wafa, you hear me?
Hi, everyone.
Hi. So how do you feel the development with MicroPython and Rust and all? Have you ever got chance to get your hands dirty with Rust, Wafa?
Actually, I never used Rust before, so this is really interesting for me.
Okay. Amazing. By the way, to both of you, I want to ask my own personal question. I run a small consulting firm here in India, and I asked my developer at one point in time to try and develop some prototype around RP 2040. And unfortunately, the feedback that I got from my team, maybe it may not be the same with you, but many of them, they told me like it still lack the ecosystem of libraries and required to do a lot of development. Is it the same for Rust? This is a question for Rafael, and the same question I would ask in terms of MicroPython to Wafa for RP 2040 target, and then we'll move to the other Rust specific questions. Yeah, we'll take first with Rafael, and then we'll go for Wafa's opinion. Yeah.
Okay. So in my experience, there is not a lack of libraries. There is one project that, or a group of projects that are like critical that every Rust embedded project has, like the embedded Hall and maybe Embassy, maybe Arctic, different projects that are in this space, and they all have RP 2040 as a primary target as well as some other chips. So I think the library situation is rather good. Also, the vendor gives good support, but Bluetooth, on the other hand, is not supported by the vendor very well yet, no matter what target language. Like the hardware can do it on the PicoW, but yeah, the vendor just didn't communicate well the data sheets and stuff.
Okay, this is specific to the Rust, right? The Rust ecosystem for the RP 2040 for Bluetooth, you mean? Or
No, this is a blob
it's a
that
hardware.
Infineon
Okay.
has to provide about the CYW43 that is doing the Bluetooth on the PicoW.
Perfect. Yeah.
And they are integrating it right now. Also in MicroPython, it will come Bluetooth via this chip, and in the C and the C++ SDKs from the manufacturer, it will come. But it's not specific about Rust.
Okay, cool. So let's go to Wafa. Wafa, what's your take on this? Like using MicroPython, let's say, for example, for RP 2040.
Actually, MicroPython is like has a lot of limitation comparing to Python. It's have like limitation libraries you can use, but it's widely common for like ESP32 and STM32 also Raspberry Pico. But it gives a lot of limitation. But it's great for using like Bluetooth or IoTs, Internet of Things. It's you have always to consider consider the limitation of the hardware because it's sorry, just 1 second.
No issues. Yeah. So all what I sorry, Brandon, go ahead. Yeah.
Yeah, I've got a quick question. So, Raphael, I really want to hone in on what is the practical difference between C and Rust. Like everybody's really familiar with using C on a day-to-day basis, or at least most people are. And now Rust is coming in, and especially in safety applications, you hear about a lot of firms or organizations who are starting to replace their C code bases with Rust, incrementally over time. So, when that happens, you're obviously, and this isn't this isn't like completely foreign. You know, there are a lot of times when you're going to see different languages and different code bases in the same system or in the same build. But that necessarily means that sooner or later, if this continues, developers are going to start encountering Rust, right? C developers are going to start running into it in places, and eventually just have to deal. So your experience, you know, what is it about Rust, number one, that allows it to be used? You mentioned some of those things earlier. You know, it's easier, you know, it's more straightforward, it's more intuitive. But especially in these safety applications, you know, how does it compare to C? And then you know, what's your daily use? Like, how do you are you using it more for a certain type of application or a certain use case or certain subsystems? You know, just give us some flavor.
Yeah, I'm a teetotaler for Rust. I do everything. I even do a lot of web front end in Rust, but that's maybe not. Yeah, it works. It does work. I mean, it's fine. In terms of the number one difference to see, it's hard to put it on one thing, but I would say it's the ergonomics. The ergonomics of saying I need a library for my SPI display, and I have an SPI device, so I go get that library. And this actually happened to me. And then I just define the graphics in a different crate, which also can be used by simulator. And I have nothing to set up. I just type cargo run and it works. But then we find that there's some problem with the SPI bus, and the hardware people change it to I2C and don't tell me. And this also happened. And I instead got the different crate for the same display with the I2C bus, crate as a library, and changed it, and within 5 minutes, my system was working again. So this kind of developer tooling, ergonomics, libraries, and this is not mentioning the safety, which obviously is the prime selling point.
So can you tell us a little bit about that? You know, what fundamentally makes it? I know I've heard that using Rust, you know, especially when you're dealing with memory, is just a little bit, you know, more safe and secure. Can you explain what that is and how that's structured?
That's like the core probably of why Rust exists. The core motivation of why Rust exists as it is now is the notion of memory safety. So this means that there is no undefined behavior ever in a safe Rust program. That means there's no seg faults, no race conditions using with threads, so no data races. Also, no globals that are being shared, no double freeze, none of this stuff. And this is done by the ownership system. And the ownership system was invented, or rather stolen from other research languages, specifically to address the issue of resource management. However, over the years, it turned out, yes, this is fine. It is sufficient to do really nice resource management. It's like RAII from C++, but more. Over the years, it turned out, okay, ownership is just another way of saying responsibility. And responsibility is the core currency of system architecture. So if you get your ownership right, you likely have a great system architecture. And I see this time and time again. People start out with Rust and they do some funky architecture and it doesn't work. And the compiler stops them from doing a working but badly architected program. And over time, they sort of anneal towards a program that is playing with the borrow checker. Okay, that is some fight with the compiler, but when they are done, the architecture also looks nice. And this is a side effect that was probably intentioned, but not really communicated. And when it turned out, we have a borrow checker that makes the resource management safe, it also coincidentally makes the architectures quite clean.
So the obvious question then becomes, if you have some of these more straightforward, you know, resource management principles, are you limited in any way using Rust versus C? You know, is there less flexibility? Is there any place where you say, okay, well, I'm not you, but I guess a normal Rust developer who wouldn't use it on the web front end, right? Is there any drawback, or is there anything like that?
Any drawbacks in general? There's a list, yes. You asked a very interesting question there. You said, is it less flexible? And I would say yes, and that's the point. Of course, if you need to do twiddly things, there is a keyword that is unsafe. For example, if you need to call a C function, you can link a C binary just into your Rust binary or the other way around. Calling a C function, of course, is unsafe, or dereferencing a raw pointer. Like references in Rust are just pointers with some extra rules, but no runtime overhead. But if you do have a raw pointer, then you do need unsafe to dereference it. So in that way, Rust is actually equal to C. However, it makes you do extra work and proof work to go to the C level. And the second part of your question was downsides of Rust in general, if I understood you right? So the first one would be obviously learning curve. It takes a while and it teaches you like half a course of computer fundamentals, unless you've had that course already. And the other downside is compilation time. The compiler does a lot of things, and it takes a while to do those. This is something that is less bad in the embedded context because your crate is not going to be that big anyway. One downside that you will see as a C programmer, and it will startle you, is if you check what dependencies your program has, like statically linked dependencies, the number will, for even a simple firmware, easily range into the hundreds. This is because you may depend on some hull, and the hull may depend on some concurrency primitive, and the concurrency primitive may depend on some target-specific implementation for this device that you have. And transitively, those dependencies make a whole tree, a whole graph of stuff that you are linking into your binary. And this is a downside. For me, this is also an upside, but that's a thing. And lastly, just quantifiably, the binaries that Rust produces tend to be like a few % bigger if you don't do extra steps than the C binary. But this is not even a universally observed thing. And that also just, I mean, in the embedded context, it matters. In the real world, no. In the non-embedded real world, it's less of a problem, but this is something that you can run into. The binary can be slightly bigger because it's, after all, just a very fresh, very new language that is constrained to not run on GCC or not be compiled by GCC, but by LLVM. And Clang tends to, or LLVM tends to make slightly bigger binaries, but that's a thing. And there's probably other downsides as well. Yeah.
Well, not to someone like you. Make a lemonade out of the lemons.
Yeah.
So, you know, Umesh started touching on it when he was asking about the RP2040, and then you went down this path a little bit too, which was, so it's a relatively new language. Are all of the resources or all of the tools, or, you know, like they're clearly not there yet, but does that become an impediment to on-ramp, you know, to getting up to speed? Do you have to be like totally gung-ho, I'm gonna learn Rust in order to pick it up, or is it is there enough infrastructure there to help you get going?
I mean, bucket of salt here, but I'd say they are not here yet. They are here yet. You can go on and start programming Rust today. And I'm onboarding a colleague now for about 2 months who has done a lifetime of C++ programming. And after 1 month, he stopped asking questions and he just did everything. And he's learned Rust in 1 month. And this is, okay, he's a bright guy, but I've done this before as well. And in terms of tools, there's like official IDEs. There's really good community tooling that is better than STM32's tooling for sure. And I keep telling them. So in that context, yeah, I would say Rust is totally ready.
That's awesome. Wafa, I sent you a direct message, so send me one back if you got it. But right now, until we hear back from Wafa, I want to open it up to everybody in the room and on LinkedIn. You know, if you've got questions for Raphael, I mean, Raphael, you do more than, I mean, you train people, right? You're a trainer of Rust. Is that correct?
Yes, that's true. Yes.
Cool.
Also
so
MicroPython, by the way. I haven't done one in the wild though.
You know, actually, while I see Mike's typing something in here, but while you said there's no such thing as a MicroPython power user, what does that mean?
The point of MicroPython is that you do not need to be a power user to do it. Like my side job that I mentioned before was a MicroPython on RP2040 side job. Until the guy who did it, who is not a programmer, he did some basic in the 1980s. He did a firmware and then asked me if I could help him. And he basically did this on his own. And he's certainly not a power user. He doesn't know what a tab is. So he's like a very friendly old not power user that does MicroPython. And when I came in, we did it for a few months, and then we found out that we need to do serial communication. And MicroPython cannot, as of now, do this on the RP2040. So we switched this whole thing to Rust. It took about 2 weeks for and the resulting product is, I think, good, but it is for sure more code than what we would have done with MicroPython, like by a factor of 4 or something. That's maybe another downside that is also sellable as an upside. I forgot the question.
So I was asking if there were such thing as MicroPython power users.
Oh, yes, yes. And I think he's the perfect example of somebody who is a MicroPython user, who's not a power user, but that makes him powerful with MicroPython. You do not need to be like a embedded systems. You can be an embedded systems professional, but you don't need to be. Maybe I should relax my statement. It was a catchy phrase that there is no such thing as a power user who uses MicroPython. I did not mean to start a flame war. I'm just saying that the point of MicroPython is that you do not need to be a power user, but then you will run into the limitations, not of just MicroPython, but also of the conceptual model. And of course, you can do like Rust and C libraries that you load into your MicroPython firmware. You can do that. And that's what all the big libraries do. Like they talk to the DMA, so you don't have to, because you can't, because you're in Python. But then you can call the library, which is like the point of Python to call C code.
That's awesome. Navdeep had a question earlier, which I also echo, which is, C, if you're developing a safety application as MISRA, you have MISRA C. Is it too early for like an analogous standard for Rust? I don't know, to my knowledge, I don't know of anything like that exists today.
I mean, if you look at the MISRA rules, and I have a partial excerpt here at my job, all of them are like pointless in Rust. So you could say that in standard Rust, without using the unsafe keyword, you are already, without even wanting to, conforming to MISRA. Plus, since a few months, there is a certified compiler available, so even that angle is covered. And it's just, the compiler is actually equal to the one that you're using anyway, except with a sign and some money.
Great. The obvious question here from Ajay is that, for beginners, how do you get started? What's the best way? What are your recommendations for Rust?
I would start with normal Rust, not embedded Rust. Later, you can go into embedded Rust, because embedded Rust does a few special things that are totally awesome, but a little bit up the learning curve. I would say the good starting point would be to read the book, The Rust Programming Language. It's an online resource that is just constantly being maintained. And then just see where that takes you. I mean, the good thing about Rust is that projects on every level of the stack look kind of the same, even up to front end. So you can just do a CLI tool and a GUI and then work your way into embedded. And I'm going to send a link, if I can, to this book, if there's a chat here.
Yeah, it's all the chat button's a little hidden. It's all the way on the right, on the very corner. But if you click that, you should be able to jump in there. And yeah, we'd really appreciate any resources you can share with us, Raphael. Like your knowledge and experience here is truly appreciated, especially as we all try to build stuff together.
Thank you.
I want to take a quick jump. Keep your questions coming for Raphael, both in LinkedIn and in the chat here in the video or in the event platform. Wafa, are you back? I saw you chatted me saying that you're here.
Yes, I'm here.
Cool. Did you have some slides or something you wanted to share to tell us a little bit more about MicroPython, and then maybe Raphael, you can give us thumbs up if you agree or thumbs down if you don't.
Yeah, actually, I prepared some slides.
Cool. Let's fire them up. Do you have a share screen option?
Yeah.
I have a quick question for Raphael, if it's just meanwhile.
No, not this. I'm
Okay.
sorry. Just a second.
Sorry.
Sure. Why don't you go ahead, Umesh?
Yeah, so Raphael, I have heard somewhere that there is a hidden cost beneath the abstraction layer for the Rust, which basically in a C programming you don't have to care about it. So what do you have to say about it?
There
Is
isn't.
there any hidden cost really, or it's just what people just say about it?
So I
People
don't know
love
if
to
we can
hate on that.
believe Raphael. it's like Rust is like Raphael's wife.
Obviously, go and check why it's done and how it's done. There's a whole concept in Rust called zero cost abstractions, and I could go like half a day on my trainings is talking about zero cost abstractions, but they are truly zero cost. They may be like adding compilation cost, but in the binary they disappear completely. And this is what C++ tried to do and didn't, and Rust succeeded, and C didn't need to because it doesn't abstract. So if anybody tells you like Rust has like interpreter overhead or any kind of overhead over the abstraction, no.
Okay, thank you.
Great, Wafa, if you want to take it away.
Yes. What's MicroPython? I'm here to talk about MicroPython. First of all, I start to learn Python. And as an embedded system electronic or embedded system engineer, it's obviously I should need to use C and C++, and integrating like using hardware with Python is really I loved this idea. So this is what gets me to MicroPython. So what is MicroPython? MicroPython is lean and efficient implement Python 3. It's specialized for microcontrollers. It's designed for embedded system and IoT device, of course. It's offering high-level language, like Python is a high-level language with low-level hardware access, like ESP and STM. Provide familiar Python syntax and subsets, and it's great for Python developers to get into the embedded system development. So there's board and platforms used in MicroPython. So most popular microcontrollers to use is Raspberry Pi, ESP, STM. Also, you can use Arduino, as it's like everybody knows Arduino and use it, but it's have a lot of limitation and due to relativity, consistent memory, and the resources. So what libraries I can use in MicroPython? There is a lot of libraries you can use, but the most common one is like machine, provide access to the hardwares, pins, and the IDCs. Also, time, work with times. .pyb, like to work with LEDs and buttons. Also, MicroPython Firebase, this is actually good libraries, a third-party library to allow you to connect to microcontrollers, Firebase real-time database. Also, MicroPython DS deal with real-time clock RTC, plus the Python libraries such as OpenCV and etc. So where I can use the MicroPython, I can use it in IoTs, of course, robotics and automation. Also, I can use it in machine learning, but focus on tiny machine learning since microcontrollers have limited resources. So I'm here giving you some example to use MicroPython with ESP32. It's like MicroPython provide access to various peripheral and features such as the pins, E2C, SPE, PMW, W, and more. So include support for networking capabilities of like Wi-Fi, Bluetooth, etc. How to use MicroPython with ESP? First, you have to download and flash the MicroPython. Specially built for the SP, and then from the official website, it's provided everywhere. Then you can start executing your Python code. If you are familiar with Python, it will be easy. But if you are not, it's like not that big deal to learn it. And you can use it directly or use an IDE to execute your code, or by terminal. So there's here some interesting projects. It's using camera with SP32. Here you can enable various computer vision and image processing application, provide access to various image processing and computer vision libraries such as OpenCV, not NV. OpenCV is and that's the interesting thing in MicroPython, and you can use these libraries with the hardware devices, tracking image, filtering, and more. But you need to consider the limitation of the SP board memory and processing power. And that's it. Do you have any question?
Raphael, what do you take of Wafa's take of MicroPython?
I agree. Simple as that.
Perfect. That's awesome. Thanks so much, Wafa. I thought that was a great crash course overview of this. There are a lot of opportunities here, both for people who are not as familiar with the embedded space to get into things with MicroPython, and then obviously, as Raphael was talking about with Rust, you want to get a little bit more, I don't know, experience or advanced, or I don't know. How would you say, Raphael? Would you say this is more for a nuanced user, sophisticated user, Rust, compared to MicroPython?
Yeah, I have a slight yes there. That said, the motto of the Rust programming language since 2018 has been to empower everyone to build safe and reliable system software. That is at least the goal. Maybe a slightly inflammatory take. MicroPython is a great first language, and Rust is a great last one.
Very well said. Very well said.
Inflammatory, as I said.
I like
no
this.
harm intended.
I like this statement.
Very good. Well, Wafa, I'll ask you the same question that I posed to Raphael about Rust. In terms of getting started, what was your experience? Where did you get started, and what resources do you lean on, or would you lean on if you were just getting started out?
To start, just start. There is there's a lot. If you are beginner, you don't have hardware devices, there's a lot of simulation you can use, and just start. It's implement the MicroPython, install it, and just start using it. Actually, a great project to start with, using camera with the ESP. Yeah, that's a great project to start with, to learn the basics of MicroPython.
Awesome. So,
if I may chime in.
Sure, yeah.
The total utter superpower of MicroPython is to buy a board and attach it to the computer, and you have a shell. And with that shell, you can blink or read a word from a serial port. Nothing can beat that in a way. And you said simulator, Wafa. I couldn't resist and post a link to walkwe.com, which may be familiar to most people here, but that supports MicroPython as well.
Yes.
That's awesome. Navdeep, I don't know if you're still there, but we were talking about the PYNQ board. Somebody was asking about the PYNQ board in the server. Have you used PYNQ, and what's the relation between PYNQ and, actually, if you could explain what the PYNQ board is, and then what the relationship between Python and PYNQ is?
Yeah, perfect. So PYNQ, okay, it should all start from the system on chip. Right? So Xilinx, probably in 2010 or so, they introduced a cost optimized portfolio of their product line, saying they'll put FPGA fabric and also ARM Cortex controller in the same fabric, and then we called it Zynq system on chip. So PYNQ is a Python for Zynq, a framework built around Python, and To be specific, like it's a operating system. It's like a in a Raspberry Pi you run the Aspen OS, and it's a PYNQ OS, right? You load it over the system on chip. It boots in the ARM Cortex A53, having the Zynq SoC, and then you can tune into the local host Jupyter notebook, and then control the peripherals through this particular interface you have. So yeah, that's what PYNQ OS is, and then they have extended the support, and you can do a bunch of computer vision and sort of it. They provide some libraries around it. So yeah, that's about PYNQ OS, and then this PYNQ board, they have PYNQ Z1, Z2. These are the platforms, hardware platforms on which you can load this OS and try out stuff around it.
Awesome. So that's full blown Python though, right? I mean, you said it's obviously like an operating system, sort of an operating environment, but you're running full blown Python there, not MicroPython?
No, it's a full blown Python. Yeah.
Okay, very awesome. So, I mean, I guess today what we figured out is there are some steps if you want to get into embedded systems, right? Like if you're coming from completely not embedded, there's platforms like Zynq or PYNQ, sorry, excuse me, that allow you to just jump in right into embedded, get on an FPGA fabric, with an ARM microcontroller there. And then if you want to go further down the rabbit hole, you can use something like MicroPython to get yourself even more acquainted. And then as you advance, you will learn your last language ever in Rust, because you'll never need to know another one after that. Here's a question, Wafa, for you from Joseph. How effective is MicroPython with STM32? And I think I would imagine that a good way of thinking about how to answer this question is in comparison to something like C++. Like, how would you compare?
To compare, I think it's better to use MicroPython than C. It gives a lot of. I think C is like more limited, but MicroPython, you can use Python libraries with it.
Great. Navdeep, you're typing. Got it. That's more information on PYNQ. Well, I think this has been a great session today. I appreciate you so much, Wafa and Raphael, for coming in and lending your experience. Raphael, if somebody wants to learn a little bit about your training offerings, are you still doing that? Are you actively doing that? Is that somebody that people can take part in?
Let's say I'm open to discussions. I'm not currently planning any. Actually, I canceled all the trainings for this year because I had some other focus. I need to focus on my work after all sometimes. But I'm definitely open to conversations. I don't have a page or anything. Just if you like, you can contact me on the server, and then we can make something.
That's great.
I prefer like in-person training. I'm in the Europe area, but we can also do online. Sorry, didn't mean to interrupt.
No, your handle is at BA Raphael.
Yes, it's the first great. 2 letters of my second name. At BA Raphael. That's correct.
Wonderful. And then Wafa, what's your handle in the server?
What?
What's your username in the server? Your username in the server.
Just Wafat, just as my name.
Perfect. Okay, well, I'm going to pull the slides back up. Thank you guys so much. I really appreciate it. We'll get through the rest of the session here with some housekeeping stuff. Here we go. All right. So the next office hours, I forgot to update this. Sorry, I'm on my way to the big show, so it was a little bit hectic. But Navdeep, do you want to talk about next week? Because Navdeep's going to be filling in for me. What topic do you have lined up, and what do you got in store?
Yeah, perfect. Yeah, next week we'll be looking at component sourcing and supply chain. So as product developers, we always components are everything for us. We design it, and then without that, right, some person or some company in random corner of the world does it, and some vendor will source it for you. So yeah, let's see how to tackle these and all the runarounds and hacks which we can do, and let's also listen to what experts like Peter or Umesh have been doing for years around this topic.
Great. And then in addition, we keep having these demos that we publish on a weekly basis on various embedded and IoT development and integration topics. Next week, we're going to be looking at how to integrate peripherals into FPGA-based systems with Navadeep. The first one of those was a big hit, so we're looking forward to continuing the progression down that path with Navadeep. And then a little bit later, more build root custom packages with Abhishek. Last time we got into the menu config and started messing around with, how to start putting your packages together. Now we're going to look at how you build your own custom package, which is certainly of interest if you're getting started, or even if you're a somewhat advanced Linux user. And then further out, we're going to be looking at fundamentals of C programming, and some more around analog design with Srisha. There's a video that we posted just a couple of days ago where we used LT Spice to pick an LDO. So you want to check that out on the DevHeads YouTube channel or in the server, wherever you want. A little bit later, engineering hours sessions. So this weekend, so this is going to be what, Amesh, the 7th, April 7th, we will be having our third engineering hours, and the first two have been really, really successful. Can you tell us a little bit about what you've got in store for engineering hours on Sunday?
Yeah, so this engineering hours on this Sunday, we will be looking at how the MQTT protocol works, and we will also implement and use this MQTT protocol with ESP32 microcontroller, and we'll see how we can actually use on a real hardware and control and monitor the devices. So that's basically what MQTT is for this engineering hours. Yeah, and I'm looking forward to see you, everyone who have this engineering hours is basically for the people who have read about MQTT protocol but have not seen it actually working on a real hardware. So those people who want to see things working and discussing few technical things about MQTT, I welcome them to join us on Sunday. Thank you.
Yeah, and actually right now I'm going to try and pull up this video that we did. It was another one of those DevHead demos, except we did it with Lukas Malinowski, who's an AWS IoT ex-employee and a consultant and trainer right now. I'm dropping this in the chat because he used a Roblox environment to sort of explain the concept of MQTT. So, the publish subscribe concept for people who aren't familiar with it may be a little bit new to some embedded networking folks. So you might want to check this out because it's a really nice way to get your head wrapped around some of the concepts that Amesh is going to be talking about on Sunday. So go ahead and check that out. Obviously, we're live streaming right now. Hi, LinkedIn. And then the DevHeads website launch. We keep adding stuff to this because we're engineers, and of course pushing our deadline back. But there's some really cool stuff on there. We've integrated a GPT to help people understand how the Discord works, how the server works, and over time we're going to be pulling more and more information based on what we collectively are able to produce and solve together into the GPT. So hopefully we can build our own intelligent AI. We've named him Devin, so just call him Devin. And then other than that, continuous improvement. So obviously today was a little bumpy because of me and my schedule. Apologies for that. Thanks for bearing with us. But the community held it down with Raphael and Wafa. So thanks so much. And you too, Amesh. What can we get better at? 1% next week. No, I think maybe Peter's the only one who's ever told me that we could do anything better. So any suggestions about things we can do better, please shoot me a note. You can find me on the server at TechieLoo. You can drop the comments into the suggestion box. We're always looking for ways we can improve, and this is this place is for all of us. It's not just me, or not just Umesh. We want to make it a better place for all of us. Do you have anything for me, Umesh, that we could do better?
Yeah, I have still a lot of questions for Rafael, but we will discuss on server. I think if Rafael is here, maybe I can take one question just out of curiosity.
Yeah, sure.
Rafael? Yeah, Rafael, I
Yes,
have a I
you
have
still
an
hear me?
interesting.
Okay.
Yeah, I can hear you. Let's say I'm a user, C++ user, and I have to take this decision to invest my time in learning Rust, because we all understand I tried in last year and I invested a couple of days, and then sort of your other works come in, and then you have a mental pressure. You're losing out because Rust really takes a time. It requires your focus. So when is a right time for C++ developer to think about moving to Rust? If let's say you're already consumed and working with your projects, so what is that right time? Because I don't think somebody who is completely new should touch Rust if they don't have good background, because they will demotivate. Because I myself have got, okay, if it takes long time, then maybe I will lose out of time, and maybe it's not a good deal for me to learn. So what you want to add on this? Thank you.
Yeah, I believe nobody should switch to Rust. Nobody should switch to anything. But if you have like an opportunity to have a tiny step to a working program, let's say you have a CLI tool that downloads some JSON from the internet, deserializes it, and does some action based on that. Or you have a web server that does a very basic task. Or you have maybe, which would be great, a very simple firmware, just reads a couple bytes of a serial ports and switches some GPIOs based on that. This would be an opportunity to just try out different things, among which, of course, Rust. And you might find that it's good for you and you like it, and then you keep learning incrementally. But don't say like my next big web server will be one done in this new technology, because there will be a big adjustment of how you approach problems with any significant new technology that will teach you things about itself. Like I used to say, you're programming Python, but Python programs you. And this is the case for all the technologies that you may be learning.
And which are those industries right now these days are heavily adopting Rust? Because there are a lot of tasks which I do in a daily basis, do development, which work perfectly fine with C. Even sometimes I don't even need C++, unless I'm going for very specific, let's say, manual memory management, which I do, and it does solve my problem. And there's no dynamic memory leak issue because the program is not as big as I have to really think of Rust as my savior or my god for the solving problem. So what are those industry where you see Rust is making more sense to invest your time right now? Because of course for smaller application it may not be, I mean, the investment of learning and time and all things. So what your take on this?
Okay, so from what I can observe as a trainer, the automotive industry is betting big. And there's a lot of training demand and a lot of companies which already have like cars on the road that use it. It's all over the place. I mean, what area would you? Yeah, maybe web backend is also one area where the use is quite nice, but the utter core of like a juicy simple application, like I said, is a command line application that does something simple. That's the place I would start if I got your question right.
Okay, all right. Thank you. Take over, Brandon.
Great. Well, I was just dropping Rafi's suggestions in the PowerPoints as our resources page. This will be here, so when we upload the PowerPoint here to the Office Hours Notes page, where you can discuss and ask additional questions. I'm sure Umesh will be in there posting some more questions for Rafael and trying to pick his brain. You'll be able to find this and access it really quickly. So just take note of that. And then that's it. It's 9 o'clock. We're right on the dot. I really appreciate all of your time, both those of you who presented and those of you who attended. showed up, gave us your time and attention. There's nothing more valuable than that. So we really appreciate it. We'll see you in the server, which if you're on LinkedIn, you can access by going to discord/gg or discord.gg/devheads. And if you're already in the server, we'll see you soon.